Okay, we are recording. Number 7, from worksheet 4-2. A lot of worksheets this time, huh? 4-2, okay. Number 7. All right, so given 3x squared y minus pi times cosine of y equals 4 pi. I'm going to find the line tangent to the curve. A line tangent to the curve at 1 comma pi. Okay, so to find the line tangent to the curve, you need a slope and a point. That's your point. So we just need to find the slope. And so there's no way to isolate this y value, so you got to do it implicitly. And so we'll take the derivative of each of these. When you do the derivative of this guy, it's product rule. So I would do derivative of 3x squared would be a 6x, and then times y plus 3x squared times the derivative of y, which is a 1, but then because it's y and we're doing it with respect to x, we'll go times dy dx, and then we have a minus pi cosine of y. Pi is a number, so that's just a constant out front, so pi, and then times the derivative of cosine is negative sine of y, but then we're doing times the derivative of y, which is a 1, but then dy dx, and then derivative of 4 pi would just be 0. All right, so we want to solve for dy dx. So I've got, let me just clean this up. This is 6xy plus a 3x squared dy dx. And then that would be a what? Plus pi sine of y dy dx. And that's equal to 0. So you want to get anything without dy dx in it on the other side of the equal sign, and you want to factor out the dy dx. So when I factor it out, I'll have a 3x squared plus pi times sine of y, and I need to subtract the 6xy over to the right-hand side, or from both sides, get it over there. So then that means dy dx is going to be a negative 6xy over the 3x squared plus pi times sine of y. And what we want to do is evaluate this at the point when x is 1 and y is pi. So this will give you a negative 6 times a 1 times pi all over 3 times 1 squared plus pi times sine of pi is 0. So that guy cancels out. You're left with what? Negative 6 pi over 3, so a negative 2 pi. And that's your slope. So that's your slope. And then we have this is your point. And so together, let's see if I can squeeze it in. Did they simplify it too? Of course they did. All right, we got a y minus pi equals negative 2 pi times x minus 1. And then they solved for y. Sorry, it's so scrunched, but it'll be a y minus pi equals negative 2 pi x plus 2 pi. And then when you add the pi over, it should be a y equals negative 2 pi x plus 3 pi. Yep, there you go. There's B. C. C is your answer. Okay. That was number 7. Number 9 from chapter 4 worksheet. Number 9. So we want to find dy dx by implicit differentiation. So cosine of xy plus x to the 7th equals y to the 7th. Okay, so derivative of cosine is negative sine. I'm going to put parentheses around this because it's cosine of xy, so it's negative sine of xy. But then you need to go times the derivative of x times y, which is product rule. So derivative of x is 1 times y, and then plus x times the derivative of y, which is 1, but we're doing this with respect to dx, so times dy dx. And then a plus derivative of x to the 7th would be 7x to the 6th. There's no y there, so you don't need to go times dy dx. And then derivative of y to the 7th will be 7y to the 6th. And that's times dy dx. All right, so what do we got? A negative y times sine of xy. So I'm distributing this in there and in there. And then minus x sine of xy times dy dx. And then a 7x to the 6th, and then 7y to the 6th dy dx. All right, I'm going to collect all the dy dx's on the same side. So this first term will stay there. I'm going to add the second term. I've still got the plus 7x to the 6th. And then we have I'm going to factor out the dy dx at the same time. It's a 7y to the 6th, and then this whole term here, I'm bringing over here, so I'm adding that term, and I'm factoring out the dy dx at the same time. So this should be a plus x sine of xy. And then dividing both sides by that guy. You gotta, all right, so they wrote it with the 7x to the 6th in front, but it's a negative y sine of xy plus 7x to the 6th over, so dividing both sides, 7y to the 6th plus x sine of xy equals the dy dx. The only difference is theirs has a 7x to the 6th minus y sine of xy on top. And is it A? Yeah. So the answer is A. Okay. All right. 14 for the quiz. And I don't remember which homework was on Friday, so, and you can't ask me just do parametric. You need to find me actual problems, tell me which worksheet, which page, which number, because it's just too much for me. I'd have to look up which one was the homework on Friday. I'd have to find parametric. It doesn't work. It's too much. Okay, so which one was this? 14 for the quiz. Quiz. Oh, good. Number 14. Perfect. Well, can't ask for better than that, right? Okay, so we got y equals inverse cotangent of 1 over x. And we want to find dy dx, which is just y prime. All right, so what we know is that if you're trying to find the derivative of just inverse cotangent of just x, then that's equal to the negative of inverse tangent's derivative, so 1 plus x squared, like that. All right, so we're going to handle it that way. We got the negative out front, we got 1 over, and it's 1 plus my blah blah squared, but the blah blah is a 1 over x. But then chain rule says, all right, now you got to take the derivative of 1 over x. So the derivative of 1 over x, I'm going to rewrite that as you're taking the derivative of x to the -1 power. And so that's pop and drop. You would have a -1 times x to the -2. And you could leave it like that, or maybe it will make more sense for you to say that's -1 over x squared. And so that's what I'm going to multiply by. Chain rule says multiply by the derivative of what's inside there. All right, so we got that. So what does that become? That's a positive 1 over, and then you're going to distribute this x squared to give you an x squared plus x squared times 1 over x squared, which is a 1. And so, yeah, there you go. That's your answer. Do-do-do. All right, that was 14. Okay, number 9 from review worksheet. Which review worksheet? Maybe, oh, is that the one I just did, hopefully? I'm going to assume that that was the chapter 4 review worksheet and I just did it. Page 158, 27. Page 158, number 27, wants you to find dr d theta. That's the same thing as finding dy dx. It's just your function, instead of it being in terms of y and x, it's in terms of r and theta. But that's it. You have r equals the square root of theta times sine of theta. So I'm going to rewrite this as this is theta times sine of theta to the 1/2 power. The square root is to the 1/2 power. So now the derivative of r with respect to theta, your variables are all in terms of theta, so it's doing the exact same thing as if finding dy dx. So you'll do pop and drop on the outside, 1/2 times, leave the inside alone. We're going to do 1/2 minus 1, which is a -1/2. But then you go on the inside, and because you got to do chain rule. Now, the inside, it's theta times sine of theta. Theta is your variable. Theta is like your x. So take the derivative of theta with respect to theta. So that's a 1 times sine of theta. And then a plus theta times the derivative of sine of theta would be cosine of theta. And then technically it is chain rule also, but the derivative of theta is theta, so you don't have to worry about it. Or, I'm sorry, is 1. So there you go. All right, we're going to clean this up. That is a, what? Is it really that ugly of an answer? Yep, it's that ugly. Okay, so we got sine of theta plus theta times cosine of theta all over 2 down there. And then to the -1/2 power means you're going to take the reciprocal, so it'll be down bottom. And to the 1/2 power is rad. And there's your answer. Not pretty, but that's okay. 58G. Find the derivatives. Okay. Gotta love this chart. So same page. Well, technically it's on 159 now. And then number 58G. They want you to find the derivative with respect to x of f of x plus g of x. Okay. And at x equals 0. Okay. So you're going to take the derivative of the outside. leaving the inside alone. And then times, chain rule says, go inside and take the derivative of the inside. So the derivative of x, with respect to x, is a 1. And then the derivative, that's a plus sign there, so it's not product rule because you're adding these. And then derivative of g of x would be g prime. All right, then we're going to be plugging in, they wanted it when x equals 0, so I'm going to plug in a 0 into x everywhere. So 0 plus g of 0 times 1 plus g prime of 0. And then we'll go to the chart. 0 plus g of 0 is just we're doing f prime of g of 0. So g of 0 in the chart is a 1. And then times 1 plus g prime of 0 is 1/3. And then f prime of 1 says it's a negative 1/3. And then times 1 plus 1/3 would be 4/3. So your answer, negative 4/9. Whoop, whoop. Negative 4/9. Yeah, definitely with these notation ones, take the derivative first, all with the notation, and then go plugging in numbers. Definitely don't want to plug in your 0 into x right away. Otherwise, it'll be totally confusing. All right, number 5 from the extra chain rule worksheet. So this is chain rule extra practice, number 5. It says f of x is equal to x squared times 2x minus 3 to the 4th power. All right, so this is product rule, right? I know there's no parentheses around it, but it's like x squared times. So the derivative will be derivative of the first, so derivative of x squared is 2x, and then leave the second guy alone. And then plus x squared, which is the first guy, times the derivative of the second, which would be 4, pop and drop, right? 4 times 2x minus 3 to the 3rd power now, times the derivative of inside, because of chain rule, inside of 2x minus 3 would be a times 2. So this is a 2x times 2x minus 3 to the 4th plus 8x squared times 2x minus 3 to the 3rd. If you see, there is a 2x minus 3 to the 3rd in common. So I can factor that out, and I would be left with a 2x times another 2x minus 3, and then a plus 8x squared. And then that's a 2x minus 3 cubed times 4x squared minus 6x plus 8x squared. Adding the x squareds together, you've got 2x minus 3 cubed times 12x squared minus 6x. Okay, so you could leave your answer like that, or if you noticed that there was a 6x in common to the to that guy, you could factor out the 6x and you would have a 2x minus 1, and then still times the 2x minus 3 cubed. Either one of those answers is totally fine. All right, number 4 on the chapter 4 worksheet. All right. What do they want? Okay, suppose that the functions f and g and their derivatives with respect to x have the following values. Find the derivative with respect to x of the given combination at the given value of x. So they want you to find the derivative of 1 over g squared of x at x equals 4. Okay, so I think what I would do is write this as g of x to the negative 2 power, right? Because a negative says take the reciprocal. Yeah, and then the g squared is the same thing as g of x quantity squared. So I'm going to do that. So now when I take the derivative, all right, so the derivative would be negative 2 times leaving it alone inside to the negative 2 minus 1 would give you negative 3. And then chain rule says times the derivative of the inside. And then we're evaluating this at 4. So now we want g at 4 to the negative 3 times g prime at 4. And then you go to the chart and g of 4 is 3. So this is a 3 to the negative 3 power. And then times g prime at 4 is a negative 6. And so what is this? Negative 2 times negative 6 is a 12. 3 to the 1/3 power is a 1 over 27. So 12 over 27, that reduces. 3 goes into both. 4 over 9. I got A. Yay, A. All right. Okay, 4 from the quiz. Find dy dx by implicit differentiation. Okay, so derivative of x is 1, and then derivative of tangent, remember, psst, which means secant, secant, tangent. So if I'm taking the derivative of tangent, it's secant squared of blah, blah. So you leave that alone. Then chain rule says go inside and take the derivative of x times y. Now, when you take the derivative of x times y, it's product rule and implicit because you got that y there. So we've got derivative of x is 1, and then just times y, plus x times the derivative of y, which is 1, but with respect to x, so dy dx. And derivative of 0 is 0. Distribute that secant squared to both terms so that you'll have a y times secant squared of xy, and then a plus x times secant squared of xy, and then you still have a times dy dx. You want to solve for dy dx, so you need to subtract the first two terms. You still have this on the right or the left-hand side. And then, but you will have subtracted 1 and subtract the y times secant squared of xy. And then dividing both sides by the x secant squared, we got negative 1 minus y times secant squared of xy all over x times secant squared of xy. That was the answer I gave. There was another correct answer if you did it a different way. I'll just put it over here in the corner. And I don't know right off the top of my head, what did they do? Maybe we wrote secant in terms of cosine right away or something, but this is also a correct, perfectly correct answer. Negative cosine squared of xy minus y all over x. That is totally equivalent. Did they separate Oh, yeah, if you separate the fractions and then 1 over secant squared would be cosine squared, so maybe that's what they did, but either one of those answers is totally fine. I give the one on the right, the original one, but either one is fine. Okay, so that was 4 from the quiz. I meant 9 from 4-4. 4-4, number 9. Okay, so 4-4 worksheet number 9. At what point on the graph of y equals 2 to the x plus 3 is the tangent line? So at what point on this graph is the tangent line parallel to y equals 5x minus 1. Okay, so parallel. Well, your slope is 5, right? The slope is 5 there. And parallel means same slope. So you just want to set the derivative of this guy, dy dx, and you want to set it equal to 5. So dy dx would be the derivative of 2 to the x, that's like an a to the x, would be 2 to the x times the natural log of 2, and then plus the derivative of 3 is 0. And so we want to set these two guys equal to each other. They have the same slope, so 2 to the x times the natural log of 2 is equal to 5. When does that happen? Divide both sides by the natural log of 2. Because the natural log of 2 is just a number. And then you want to take the natural log of both sides. And I would have an x times the natural log of 2 equals the natural log of 5 over the natural log of 2. Because here's what I did. I did 2 steps right there. I took the natural log of both sides, and I used the fact that now that I did that, this x can come around front and multiply instead. So now I've got x times the natural log of 2 equals the natural log of 5 over natural log of 2. And so to solve for x, you're going to have that messiness of the natural log of 5 over the natural log of 2 all over natural log of 2. And I got that it was about 2.851. And then, I mean, there's only one answer there, but, you know, you're going to plug that in to your y value. And y would equal 2 to the 2.851 plus 3, which means your x would be 2.851. And then your y value, whatever that ends up giving you, must be 10.213. And that's the point that the tangent line is parallel. Tangent line is the derivative, the equation of the tangent line, and the slope is the derivative. And then if it's parallel, then it's going to have the same slope. Okay. There was Andy. There you go. There's the example of a to, well, I did a to the x, but so Friday, okay, 4-4. That was probably before. Can we please do number 5 from the quiz and give us an understanding of how much we need to simplify? Okay. All right, so I got x cubed plus y cubed equals 1. For dy dx, you got to do implicit, right? So you're going to take the derivative of x cubed, which would be 3x squared. Derivative of y, 3y squared, but it's y, so times dy dx. Derivative of 1, be careful there, is 0. I see a lot of times students will say it's 1, and then your answer is really horrible and wrong, and when you go to find that second derivative, you're going to just cry. It's already bad enough, right? But anyway, all right, so subtract the 3x squared and divide by the 3y squared, and you end up with, the 3's will cancel, you end up with a negative x squared over y squared. Don't simplify that more. That is dy dx. Now, when we go to take the derivative of this guy, so that was part A. That was dy dx. All right, when you go to find the second derivative, you got to take the derivative of the first one. And so we're taking the derivative of the negative x squared over y squared. Quotient rule says you take the bottom times the derivative of the top, which would be a negative 2x. Don't need a dy dx because that was x, minus the top times the derivative of the bottom, which is a 2y, now to the power of 1, but then times dy dx, and then it's all over the bottom squared. All right, so then what you want to do is we're going to simplify this, and we're also going to stick the dy dx into that dy dx right there. So that we've got negative 2xy squared. This would be what? Plus, I didn't mean to make that look like a prime. That was a to the power of 1. Okay. Plus 2x squared y, and then times a negative x squared over y squared. And then that's all over y to the 4th. All right, I'll say this, you definitely do not want to leave a fraction within a fraction, which is what I have right now. Like, that's just not okay. It's not proper. So you definitely need to be simplifying. One thing you can do right away is this, where am I? Right here. This y divided by y squared will leave you with just a y in the bottom right there. And so this is like a negative 2xy squared. It's going to be a minus 2x to the 4th over y to the 1, and then all over a y to the 4th. And then what you want to do is, this is like over 1, and to subtract fractions, you need a common denominator. So I'd multiply top and bottom of this fraction by a y, which means I've got, can I squeeze it up here? I think I can. Okay, so now I'm coming up here. I've got this would give me a negative 2xy cubed over y minus a 2x to the 4th over y. So you can combine those and put it over y. And then it's still all over y to the 4th. And then, again, you got a fraction within a fraction. Can't leave it like that. But this is, you can just kick this y down below, or you can think of it as, instead of dividing by y to the 4th, it's multiplying by 1 over y to the 4th. And so 2xy cubed minus 2x to the 4th over y to the 5th now. That was the answer I gave. Let's see, did I have another answer? No, that was the only one I wrote. But there you go. So as far as simplifying, don't leave a fraction within a fraction. Other than that, if it's a simple simplification, you should do it. If it's really crazy redonkulous, maybe you don't spend your time doing that. Okay. What are we on? We are on number 6. of the quiz. Okay. Okay, I want to show you one thing real quick before I do this. If I have the graph y equals x cubed, let's say, it is a swimmer stroke going up like this, right? And this, let's say, this point right here is 2, 8, right? The tangent line would be like right here. And we actually know what the tangent line would be there. It would actually be what? Well, the slope of the tangent line, right? The slope would be 3x squared. Evaluating that when x is 2 would be 3 times 4, which is a positive 12. So a 12 over 1 is the slope of the tangent line right there at x equals 2. Now, if we're talking about the inverse, that means x is equal to y cubed, because you flip your x and your y, right? That is still a swimmer stroke, but it's kind of laying on its side like that, something like that. And now you've got this point here, 8, 2. When y is 2, 2 cubed would give you 8, so your x is 8 and your y is 2. And now you've got a slope like that. And, okay, I'm showing you too much, but this would be a x to the 1/3 would be y, and so your slope would be a 1/3 x to the minus, so a negative 2/3, and you were evaluating that when x is 8, right, which will end up giving you a 8 would be, cube root of 8 is 2, 4, so this is a positive 1 over 12. So your slope is here, positive 1 over 12. Slope is a 1 over 12. Okay, so I'm showing you this because this is the whole point of finding the slopes on inverses, right? You have corresponding points, 2, 8, 8, 2. The slope of this original guy is 12 over 1. The slope of this guy is the reciprocal. And if you look at the graphs, it makes sense, right? So, taking that information, let's look at number 6 on the quiz. So, reciprocal slopes, right? Or the derivatives are reciprocals at corresponding points. And corresponding points are, look, when x is 2 here and y is 8 here, then your x is 8 on the inverse and 2, right? They're flip-flopped. Okay, so here's the process I do for this. They gave us f of x is x cubed plus x, and they say g of x is the inverse of f, and they also tell you g of 2 is 1, and what is g prime of 2 equals what? Okay, so here's your original function, here's your inverse. They gave me this point on the inverse, that when x is 2, y is 1. So the corresponding point to that on the original is flip your x and y, 1, 2. All right, now take the derivative. So you're finding the slope right now of your original function. The derivative of your original function would be a 3x squared plus 1. You want to plug in the x value into that guy. So f prime of 1 would be a 3 times 1 squared plus 1, which is a 4. That means the derivative of your inverse function at 2 corresponding points here is just the reciprocal, 1 over 4. You're just going to take, whoops, I meant to point all the way to there. Take the reciprocal. Not negative reciprocal, just reciprocal on that. Corresponding points have reciprocal slopes. So Hopefully that makes sense. You're welcome, Allison. I think that was from before, but whatever. Okay, so that was number 6 on the quiz. Now you want to know if there are questions like page 167. Numbers 13 through 16. So all that 13 through 16 is finding the derivative and then making sure it's defined, which is where your denominator would be 0. 13, 15, 16. Where's the answers for 13 and 14 up there? Yeah. But no, I don't think we asked that. But you want to make sure it's you would take the slope is the derivative, so you would take the derivative and then make sure that it's defined, and it's defined when you're not dividing by 0. If there happened to be a rad, it would be, you want to make sure there's no imaginary numbers, so you would want positive underneath there too. Good. Yeah, that's great. Okay. Number 17 from the quiz. All right, so you want to find the derivative first of this guy. Ooh, lots of chain rule. Okay, derivative of the natural log is 1 over the blah, blah. So it's that whole big blah, 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 blah. But then times chain rule says, take the derivative of the inside. Derivative of x is 1. Derivative of 4 is 0. Derivative of e to the negative 3x is e to the negative 3x, but then times, so there's a chain rule inside of a chain rule, the derivative of negative 3x would be a negative 3. All right, so we've got what? All of that's going to be up top. So the bottom is an x plus 4 plus an e to the negative 3x. Top is a 1 minus 3 e to the negative 3x. And we want to know at x equals 0, what is this? Well, it's a 1 minus 3 times e to the 0. E to the 0 is 1 over 0 plus 4 plus an e to the negative 3 times 0. Okay, so then that is a 1 minus 3 times 1 and a 4 plus 1. So I got negative 2 over 5. Yep, yep. Answer was A. All right, can I do number 15 from the quiz? Oof, yes. That was a long one. Okay. So you've got y equals sine of x to the power of x. So this is a function to another function, right? So you can't use the rules of pop and drop because you don't have a number up there in the exponent. And you can't use the rules for like a to the power of x because it's not a constant as your base. This is a function to a function. So this is the example of this is a function to the power of a function. And when you have that, you've got to do, what do we call it? Logarithmic differentiation. You've got to take, you want to get that x out of the numerator, it's been a long day. You want to get x out of the exponent. And to do that, you're going to use natural logs. So I'm going to take the natural log of both sides. Natural log of y equals the natural log of sine of x to the x. Now, the whole reason why we do this is because now the laws of logarithms say I can take that x and bring it around front and multiply it now instead. All right, so this is x times the natural log of sine of x. Oh my goodness, sorry. All right, now we're going to take the derivative of both sides implicitly because there's no way to get, well, that's not true either. I think it'll be ugly if we try to get y by itself though. Yeah, because then you're doing that and then, okay, we're going to stick with implicit. Derivative of the natural log is 1 over y, but then you go times dy dx. And then this is product rule. So you want the derivative of x, which is 1, times the natural log of sine of x, and then a plus x times the derivative of the natural log of sine, which is 1 over the blah blah, and your blah blah is sine. But then chain rule says go inside and take the derivative of sine, which is cosine. All right, so that means we've got a natural log of sine of x, and we've got an x times cosine over sine is cotangent, so I would change it to cotangent like that. And then you could multiply both sides by y to solve for dy dx. And then don't you dare leave a y in there. You're going to take that now and replace y with sine of x to the x. Plug that in there. And so your final answer is sine of x to the power of x, and then times the natural log of sine of x plus x times cotangent of x. That's messy enough. You could distribute, but if I would leave it just like that and don't make it worse. Okay, that was 15. Okay, sorry. I promise I'm trying not to yawn. All right, what else? I caught up already. Dang, that was fast. You've got me for, looks like 10 more minutes, 11 more minutes. $16 from the quiz. All right, so a particle moves along the x-axis so that its position at time t greater than 0, or equal to 0, is given by x of t is inverse tangent of t. So that's its position function. They want you to find the velocity. So velocity is the derivative. It's the derivative of this function, which for inverse tangent is 1 over 1 plus the t squared. And so I'll call that v of t. And so your velocity at, they want, find the velocity at, so at t equals 3, you're going to just plug a 3 into t. 1 over 1 plus 3 squared, which is 1 over 10. I didn't give any units, so whatever. Just do it like that. It's probably like meters per second or something like that, but that's totally fine. Sorry. Is the parametric on the test the same as quiz number 2? I don't know. Possibly. That is number 2 on the quiz is a parametric question. So remember, for parametric, all it means is that you have x defined in terms of some other variable, cosine, or t is what this one is, and you have y defined in terms of some other variable. Parametric is super common in physics anyway. So like you can think of t as in time, and so x equals 2 cosine t gives you your horizontal change, or not change, but your horizontal position, and y is going to give you your vertical position in terms of time. And so when we want the slope, dy dx, what you got to do is, y is in terms of t, not in terms of x. So you got to take the derivative of y, but with respect to t. And then x is in terms of t, so you're going to take the derivative of x with respect to t. If you notice these fractions, dy dt over dx dt, they both have the same denominator, so the dt's would cancel. So these guys are equivalent, right? And so dy dt would be the derivative of sine, which is cosine. dx dt is the derivative of 2 cosine of t, so that would be a negative 2 sine of t. And you're evaluating it because it wants it at t equals pi over 3. And so that is cosine of pi over 3, that's 60 degrees. So that's a 1/2. And a negative 2 times rad 3 over 2, which makes it a negative 1 over 2 rad 3, which is a negative rad 3 over 6. That's your slope. To get a point, you just got to plug in pi over 3 into t. So your x value is 2 times cosine of pi over 3, and your y value is sine of pi over 3, which means that your point is a 1 comma rad 3 over 2. So that's your xy, and you've got your slope, and so a y minus rad 3 over 2 equals negative rad 3 over 6 times x minus 1. Boop, boop, boop. There you go. So it might be something like that, but even if it's not exactly like that, I mean, that's how parametric works. X and y are both defined in terms of t or some other variable. Okay, I'm not going to yawn. Nope. Fighting it. Page 175, number 10. Okay. They say x of t is inverse sine of rad t over 4. And did I write the right problem? Okay, yeah. And they want particle moves along the x-axis so that its position at any time t greater than 0 is given by this. So this is the position function. They want you to find the velocity equals what when t equals 4. All right, so your velocity is going to be the derivative of this guy. And if you remember, the derivative of inverse sine is 1 over square root of 1 minus your blah blah squared. And then your blah blah is the rad t over 4. But then you need to do times chain rule, or you need to do chain rule, which means that it's times, go off to the side over here. So this is like 1/4 t to the 1/2 power. Square root is to the 1/2 power. Divided by 4 is like times 1/4. So when you do pop and drop, this would be 1/4 times 1/2 t to the 1/2 minus 1 gives you a negative 1/2. So that means it's like a 1/8 rad t, like that. And then should we just plug it in? That's what I'm thinking. They want you to evaluate it, so why even simplify, right? They want it at when t is 4, so let's just plug it in. When t equals 4, then let's go with, it's a 1 over square root of 1 minus, all right, when t is 4, you'd have the square root of 4, which is 2, and then over 4. Obviously, I could have simplified that, but I didn't. And then all over 1/8 times rad 4 is 2. Okay. Maybe I should have simplified. I would have made my life easier. Okay, what is that? 1/2 squared is 1/4. So you've got a 1 minus 1/4 times a 1 over 16. So what is that? 1 over 16 times the square root of 4 over 4 minus 1 over 4 is a 3 over 4. So that gives you a 1 over 16 rad 3 over 2, which is a 1/8 rad 3. Did they leave it or did they rationalize? What number is this? 10? They rationalized. So go times rad 3 over rad 3, which will give you a rad 3 over 8 times 3 is 24. All right, that was a good inverse one with chain rule. Love it. All right, that was 175, number 10. Number 11, chapter 4 worksheet. Number 11, chapter 4 worksheet, there's a typo. So tell me if you still want me to do it. Ask me for this, Allison. Chapter 4 worksheet number 11. Your correct answer is E, because I think I did it in class and I think the answer is -1 is what I got. Do you still want me to do that one? The correct answer was not there. I don't know where the typo was on that problem. Maybe because the previous problem had to plug in a 14. I don't know what, but yes, okay. All right, so we've got, this is again, they want you to find the derivative of the inverse. So you've got f of x is cosine of x minus x. Okay, so you've got your original and you have your inverse. And they gave you that the inverse, when you plug in a 1, you get a 0. So they gave you this point, which means you're going to come over here and you're going to flip it. You're going to find the derivative, which is negative sine of x minus 1. You're going to plug in this x value, f prime at 0, which means it's negative sine of 0 minus 1, which means it's a sine of 0 is 0. So you got a -1, and then you flip it. So f wait, find the value. Oh yeah, wait. No, that's fine. Find the value of the derivative. Okay, so then the value of the derivative, so the notation is weird. This just means take the reciprocal. I got the answer was -1, which, so it's E. I think it was a typo. If you see something like 16 on the quiz. Will you be given units? I doubt it, but maybe. You know, velocity would be meters per second usually. I mean, it could be anything. If you're given units, then you should include units. If you're not, then don't worry about it. Okay, I think that's time, yeah? Any other last minute questions that I could answer in less than a minute? Make sure I didn't miss anything. All right, you guys are welcome. Good luck. I'm going to post the video in just a second in this chat window. You guys are all very welcome.